Hi, in this last question from November 2020, we are looking at transformations in trigonometry, and we've arranged there from 0 to pi. So now we see our little details. We have an amplitude of 3, we have a periodic pattern of 2x, and a phase shift of +2. So just drawing our normal cosine graph there, our maximum and min goes from 1 to -1. And I'll just write out the full one there from 0 to 2 pi. So the amplitude is 3. So in this case, it's going from the origin to the maximum and the minimum. And you can see I'm drawing little bits and pieces here. Do it in installments. Wonderful drawing as usual. And the second part we have 2x, so that is our period. The period for sine and cosine is 2 pi over b, and the last part there is +2 is a vertical shift, and we've no horizontal shift at all there except for the period. So same applies for cosine and sine and tan. Of course, the periodic pattern for tan would be pi over b. Just be careful with the 2x. So that's going to be a squash. So squash in on the x-axis. So our maximum and min, the greatest and least values of y, go up to, so you'll have 3 plus 2 is 5, and then move up again from the minimum of -3, so you'll get -1. Those are our two parts there for that. Now we're going to complete our picture, in a sense, with this sketch of the same thing, and doing it in that order that we did. So squash it in, so it should go from 0 to pi instead of, like that, but I'm not going to use all of this. That's what it would have been originally, and we don't need anything from the halfway point onwards. So that should be more or less it there. I'll just scribble that back in. So that's our sketch. We have the amplitude, we have the periodic pattern squashed, and we had our vertical shift as well. And just put in those markers there for pi over 2 and pi as well. Okay, that's part B. Part C, we're given a consideration for a straight line where y is equal to kx. So making our original function equal to kx, where k is equal to, in this case, -3. So where would that go? So we can do a series of straight lines here. So -3x as a gradient does not touch our function, does not touch our graph. So stating the number of solutions, we have none. And then we have two more of these. We have k is equal to 1 and k is equal to 3. So they'll be going up to the right hand side there. There's approximately 1, and there's approximately 3x. And as you can see, our k is equal to 1 will have two solutions, and k is equal to 3x, kx is 3x, will be one solution. So we can write that in as well. So two solutions and one solution within the range that we were given. So that's that done. So part D, and we have part E as well. We have functions given, so f, g, and h are defined by x is equal to all real numbers, and we're looking at g of x as a sequence of the transformation to map from f of x. So we can see that there was a stretch, and there was a shift as well. So we're looking at a stretch of scale factor a half in the x direction. Be careful with the x, with the horizontal shifts, and there's a translation. So you can write down the words here if you want as well, or you can just do the column vector, so translation of up 4. So you might write down the two ideas of that as well if you want. To describe it, part E, you can see a transformation as well. So for the other one, so we have 2f of x, which is again a stretch, and we have a translation within. So that's on the x-axis. So again, be careful with the horizontal shifts. You're doing these in the other order, so it's different to the normal arithmetic, we say. So in this case, we have a translation of pi over 2 left, which is minus pi over 2, 0. And then we have a stretch in the y direction, scale factor 2. And that's pretty much it. Just be careful with the combinations of horizontal and vertical shifts, or transformations, I should say, for those parts and those kinds of questions with there. Okay, and that's the full lot. That's the last question for that November 2020 Series 2.